Hello everyone, this is Aves. I'm sort of a place where it will echo a lot, but I think it's the best time to make this video. So today we will be looking at paper 5, and I've selected the specimen paper from 2022 because I wanted to basically share if something is different as well. So speaking of this, you will have 1 hour 15 minutes. I would ideally spend about 30 to 40 minutes on question number 1 and the rest of the time for question number 2. But the less you spend on question number 1, it's better because it is very simple. Now, when you look at the paper, you will see that sometimes they will give you a diagram, sometimes they won't give you the diagram. So whatever it is, you make sure you read everything very carefully. So it says a circular coil P carrying an alternating current, all right, produces a changing magnetic field. When a similar coil Q is placed with its center at X, as shown, like they've shown, this is the center, EMF E is induced in the coil. Fine. Now they say it is suggested that E is related to X by this relationship, and where I is the current, K and Z are constants. Plan a laboratory experiment to test the relationship between E and X. The moment you see this, you should remember that this is the question about these two, and then explain how results could be used to determine the value of K and Z. This is very important. So let me just break it down. So your whole question will be broken down into generally 5 parts, but you could also do it in 4. Now when you look at it, you will have a space for diagram. Diagram making is very important and it should not be skipped. But before making the diagram, you should write a problem statement. Now problem statement means that you're defining that what you're looking at, which means that you will end up writing 2 things. You're going to write independent quantity. You're going to tell us what is dependent, and then you will also tell us what is constant here. So 3 things. Writing this correctly, this section, gives you 1 mark. Writing this will give you another mark. So the problem statement is of total 2 marks. So independent quantity is a quantity which basically you can control, right? And dependent is that if you control something, then the other thing changes automatically. So in here, the X, which is the distance here, as you can see, is independent because you can control it, all right, and E changes because of that, so E is dependent. However, we need to make sure that there are other factors into play. So you look at the equation, you see that there is I, which is also influencing it, so the current should stay constant. So I must stay constant in coil P, where it is, applied. The next thing you got to do is you have to write the method of data collection. Now method of data collection is that you're explaining how I am going to use the whole practice if I set up one, and then how will I get each quantity that I require. So the ideal way is to make a detailed diagram. Now if you look at it, there are two coils. I'm going to make a coil. Right. Give them a space and make sure it is a neat drawing, well built. Now coils can't just stay hanging in air, so you gotta make sure that you hold them, and holding them is super easy. So what you can do is you can use a stand. Just draw a neat drawing. You don't need to be like an artist to do it. Just take your time in here. Make sure you draw completely neat drawing. Okay. So you got the stands, and now I would suggest that you have a boss here, and with the clamp you have clamped it. Same here, boss here. With the clamp you have clamped it. So both coils. So I believe the first coil was P, the other coil was Q. So I'm going to write coil P, coil Q. I'm going to label them. Labeling is very important. Stand with clamp, stand with clamp. Now naturally, because these are just coils, we need to find this distance between the coil X. So what we're going to do is you could use either another stand or the same stand to basically clamp a ruler so this is the meter rule that you have connected like this. So now we already know that, okay, this will help us find basically this distance, which is from here till here. Mark it X. Now the first coil, if you look at it, it needs to be supplied with a variable supply. So I'm going to take two wires out of it, and then I'm going to connect a supply like this, AC supply, because if it's not AC you can't connect it. On this side this should be connected with, this should be connected with a voltmeter, and label it so that we know how much EMF is induced. Now everything that we have we wanted to is there, and the diagram is complete, self-explanatory. There are the two coils and they're going to induce some current while we can change X. There is a meter rule as well. Once you do that, so the diagram basically will have total of, usually they make like 2 or 3 marks, but it's usually 2 marks. So making the whole diagram and the right circuitry gives you this. Then you start writing how to calculate stuff. Like for example, you could say that measure X using the clamped ruler near the coils. Alright, so you have done it, or in the diagram you've also shown it, so you don't have to explain a lot. Then you say one of the biggest issue is that you don't know exactly that it should come from the center, and we don't know exactly how to locate that. So if I were you, I would write that so basically you can take width of each coil and divide by 2 to get the center, right? So sometimes you can't show that on the drawing, but that's fine if you've written it and they know that okay, you can actually find their centers through a formula, so they will understand. Then you could say that for each reading of X, use a voltmeter to find EMF E induced in coil. Of course, that coil was Q. Now, this basically comes usually is of 4 marks. So sometimes diagram gets 2, and the rest I just like to write some extra points as well, because it's always safe. Because the idea is that he's not going to cancel out anything that is extra. He is going to read that too, and let's suppose you've done something, missed a point or something, so you can cover up there. Once you've done with method of data collection, you can then move to the next part, which is called the analysis. Now in analysis, it is very important to write couple of things. First point would be, I would just tell you, plotting a graph. So this should be always there. The second point that you would want to find is answer this question: what does the gradient show? And then you need to answer the question which he has asked, that in this one, that explain how the results could be determine the value of K and Z. So you could say find values of K and Z. So these are the 3 things that you need to answer in the analysis. Now let's check it out, and one by one let's do it. Now plotting a graph, so I will write plot a graph of E on y-axis. Why y-axis? Because it was the dependent quantity, and X on x-axis because that is the independent quantity, right? Now, then what I'm going to do is, for the second one, I'm going to check out the equation. So if you look at the equation, it is E equals to IZ E minus KX. So E equals to IZ E minus KX. I believe that is this. I don't know if Z is capital or not. Let me check. It should be written in the same way. It should be written in the same way. So if I now want to draw a graph between this. So what do? First of all, I'm going to take ln here. So if I take ln e, this will cause this to be ln IZE minus kx. Now you have to have some knowledge about logs, and then you can write ln IZ and plus ln E minus kx. I'm just doing an extended thing, but you can actually skip some steps if you know logs. This will be this will be minus kz, and ln E basically is just equal to 1. Now you can write it down then. Ln E equals to minus kz plus ln IC. So basically you can always do that. Now first of all, if you look at the graph, now you can compare this with y equals to mx plus c, and you realize that this relationship is going to be there. So I could just write that, okay, this relationship is valid if a line of best fit is drawn. By the way, I have to write straight line. Best fit is drawn that has a y intercept of ln IZ, right, and gradient equals to minus k, right. So basically what you did was you actually answered the question about how the gradient varies. So I'm taking a lot of space, I should not. So this can only be done if you do this, otherwise you will be pretty stuck here. So I've answered the first question, I've answered the second. Now I'll tell you how to find this. So to do this, always remember that because he asked for the variables, so I'm going to write it here. I'm going to say k will be equal to minus gradient of this equation, and to find z, so y-intercept equals to, just write y-intercept, not c. Y-intercept equals to ln IZ. Now I'll take the log. So this will be E y-intercept. I'm going to take E on both sides, right? Equals to IZ. Now it means that z will be equal to E of y-intercept divided by I. And this is how I'm going to tell him that you find E and K right here. So I'm going to get a total of, I think, 3 marks for this, for each question. Now, the other idea is that when you're done with this, you also need to add a safety precaution. Now, safety precaution varies dependent on the type of experiment that is given. So you can always, when you practice, make sure that you practice enough papers to see which safety precaution works for which kind of experiment. Right now, it is sort of, a coil, which means that when the current goes through a coil, it causes heating. So if I were you, I would wear gloves to move the hot coil, because we need to change X, right? So it's best to wear gloves. I would write this. Now, then once you write this, this will hold 1 mark for you. So up till now you have actually had 1 here, 3 here, 4 here and 2 here. So basically you got like 10 marks, and for the rest 5 marks you got to write some additional details. Now additional details basically mean that how would you improve the experiment, and if there is something that causes large uncertainty which you have drawn or you have used, how to kind of replace it or do it in a better way. The more additional details you write, the better it is. And sometimes the additional details you already written in the paper, like doing this whole thing is an additional detail. So if I proved that this is like the y-intercept is equal to IC, so it means that I already got 1 mark. But I still suggest that because there are no negative marking, so no matter how many additional details are there, you please write extra in this. So let's write first one. Always remember to whenever the magnetic field question comes, make sure that you use either a large current or more number of turns. This is because it produces large EMF, right? So always make sure that this is something there. Then you could also use AC voltage of high frequency, because the greater the the smaller the time, the greater the frequency, the flux change is going to be rapid, which means you will get higher value of EMF that reduces the uncertainty. Then make sure that while taking readings of each of EMF, make sure frequency is constant, because it should not change at any cost. So make sure that. If I were you, then I would also write that repeat value of X for different parts, because of course it is you're moving it, so there might be something wrong, and take average. Then for another point, just to be sure, alright, you could use a spirit level. Spirit level is a device to ensure the ruler is horizontal. That could really help you. And the 6th point, you could always use a set square to make sure that coils are parallel. I've taken up some space because I was actually explaining something as well, but you should be good enough with using the same space. And always make sure that you write these 2 lines that I've written. The relationship is valid if it's a straight line of best fit, drawn y-intercept, and doing all this will get you another mark. So overall it is a very simple thing to do. The only thing is that you need to be focused on the drawing aspect. It should be good with details. You should have ample knowledge of different problems with certain instruments. You should also know that for like magnetism, electricity, or mechanics, what could be the improvements that might be there, because this is the most important part, which basically grants you like 5 marks. So I hope you understand this. If you still have any questions, you can always contact me, and I'm ready to help. Thank you.